All right, CNT125, Chapter 8, we're looking at the section on subnets in IP6. Now, just a future note, we are going to do a lab where we implement an IPv6 network and route traffic through. So we are actually going to do a little bit of this. So a little bit of foundation here is going to be helpful for us. Remember with IPv4 addresses is 32 bits. 2 to the 32 gives us many possible IP addresses. We've actually run out of those. So IPv6 came along. This is something that is slowly replacing the IPv4 need. So IPv6, 128 bits, 2 to the 128 possible IP addresses. So we have 3.4 times 10 to the 38. So add 38 places behind, add 37 zeros behind the 4 there. That'll let you know how many possible IPv6 addresses there are. So with IPv6, we do need to remember a couple things. Hopefully you remember this from Chapter 3. Classes are not actually used for IPv6. There is no class ABC like we had with IP4. Subnet masks are not used. We don't have the 255-255 kind of thing like we did at IPv4. And a single IP subnet is capable of supplying this many IP addresses. So we have a lot to work with. We don't have such the concerns like we did with IPv4. If we look at an IPv6 address, and I'm pretty sure this is the one that was in the book, I tried to copy in here for you. If I take this IPv6 address, roughly the first half is our network prefix, the second half is the interface ID. That's the basic structure of an IPv6 address. So the first 64 bits, the first half here, is the network prefix. We could consider that the network portion of the address. Network prefix, or they also call it the site prefix or global routing prefix. You might see all three names thrown around there. All right. I think in some of the pictures they use site prefix. That's basically the network portion of the address. If I see a /64 behind it, that's letting us know that 64 bits are being used for the network portion of the address. The last four chunks of numbers, 1, 2, 3, 4, the last half of the address is the interface ID. This is identifying the interface, the actual node, if you will. This is typically based on the interface's EUI64 version of the MAC address. A lot of times you will see the MAC address, which is 48 bits, turned into a 64-bit number and used in the tail end of the IPv6 address. Hopefully you remember in CNT120 we did an IP6 lab where we did just that. We used the MAC address, the last chunk of the MAC address, to make the tail end of the IPv6 address. That's exactly what we did. We'll end up doing that in our IPv6 lab as well. We'll use the MAC address for the last part of the IP address here. So that is called the interface ID. You can consider that almost the host portion, if you will. Here is this is the picture they have in the book. There's your site prefix, your network piece, and then this is your interface ID out here, basically the node or the host portion. So for IPv6, they've actually allocated, they said, okay, this block right here at the end of the site prefix is set aside for subnetting. So basically, if I look up here at this number, this last piece right here can be used for subnetting. When we do our IPv6 lab, that's what we're going to do. We'll allocate these first two as like network, and then we'll use, I think I even use AA, AB, and AC for our subnets in our network. That can be used for the subnet piece. That's what it's been set aside for. So plenty of, with those 16 bits, I can create up to 65,000 subnets. So plenty of options in there. That's what we'll end up doing when we do our IPv6 lab. We'll use that block right there to create our subnets. And really, yeah, I can do 01 for the subnet, 02 for the next subnet. I can do A1, A2, A3, A4, B1, B2, B3, B4, and organize it that way. I don't need to do any special barring bits and that sort of thing like we did with IP4. A lot easier to deal with, but they are longer numbers to work with, and as we find out in the IP6 lab, they can be a little more tedious to deal with. So there's subnets in IP6.